what's coming up really soon is through the First at Home program, there's curriculum being developed for the Romi. So you'll be able to go and do some online classes about how to do that. And for that, we have Lori Birch, who's in charge of all that stuff, who's going to talk a little bit now about how that's going to work. So Lori, thanks.
Thanks, Brad. So for those of you that don't know me, my name is Lori Birch, and I'm based out of Colorado. I joined First a little over a year ago, and I'm formerly an FRC and FTC coach. So I coached FRC for 6 years before I switched to FTC because I taught in a very small rural school district in Colorado, and FTC became a better fit for us. So part of my job in this as a manager of digital instruction is really to provide resources for teams to be able to do this in a way that it kind of coordinates with the education that they might already know. And so what I'm working on doing is really developing an at-home project that you can do with the Romi Robot. So I'm working on developing a scenario for a game that you can do on your own, that you could do individually at home, or you might be able to pair with another team or two teams and make this your own game. And then leading you through that process of, okay, how do I really take a little bit deeper dive into understanding the hardware and the software, and then how do you design code around that and really decompose and use computational thinking in decomposition and abstraction, pattern recognition, and really understanding these details of the Romi Robot so that when you come out of programming it, you have a better understanding of how does this really relate to an FRC robot, and then how can I do this at home? So that's really our goal within the education department at First, which is what I'm part of, is to provide you with those resources to make this a little bit easier and kind of scaffolding that information in a way that you might be able to dive into those details and correlate it to some of the other things that you're learning. And we look forward to producing those for you. Hopefully they will be out sometime in January, so you'll have to look at our First at Home page and stay tuned to team updates and the marketing emails that you'll get that will give you that information.
All right. Hey, thanks, Lori. Oh, am I?
We're good.
Okay, thanks, Lori. That was great. And I'm really looking forward to seeing a lot of the stuff that you're coming up with, and I think the teams are really going to appreciate that. Really get a good, spend this time getting a good head start in doing robot programming. So then it's particularly relevant right now, during this Hour of Code week. And so that's pretty awesome. Okay.
And those lessons will be all free on the First at Home webpage when they come out. So.
Okay. Yeah, so everybody kind of keep an eye on that. And all this stuff is going to be showing up really soon. And I'm sure there'll be more blog posts and other information about it coming out as this stuff gets released. So what we're going to do now is we're going to write a program for the Romi, so you can kind of just see how to do it. And actually, I'm going to let Grant write the program. I'll talk about it.
Let's go.
Because he's like much better at this than me. So the idea here is I kind of borrowed this from some VEX course that I saw somewhere. But we're not going to talk about that anymore. But the idea is that we want the robot to start at position 1 here, and then get over to position 2 without crossing any lines. So Grant is going to show this. I guess we can get a close-up shot here of Grant doing this. Wait. All right. Oh, there it is. So what's happening is that the robot's going to start here, and it's going to drive forward, and then turn with sound effects. Okay.
The sound effects are necessary.
Okay. And then drive there, and then turn again. Turn there, and then come back, and then park in over here. So that's what we're going for, and so we're going to write a program that does all that stuff.
That was really exciting.
That was exciting. That was, and I, it was like really exciting, especially with the sound effects.
Of course.
So what we want to do, and by the way, I just want to point this out. Have this little roll of tape. Some of you guys have been noticing that sitting here. It's really important with just like you do with FRC robots, or other, any robots, when you're testing them and working on the code, to keep it blocked so that it doesn't if you have some problem with the robot or some problem with the program or something, the robot doesn't launch, and fly off the table. because that would kind of ruin your day. So that's what the roll of tape is for. Okay, so that's what we're going for this sample program, and so we're going to use a technique called command-based programming for writing this thing. And the idea is, and by the way, just to make it clear, I think I said it before, but I just want to make sure everybody understands that programming the Romi uses exactly the same tools and exactly the same libraries that you use for programming your FRC robots. And so everything that you see here that we're doing with the Romi, Grant will continue to do with the FRC robot that we got here, the little desktop FRC robot, and then we're going to and just use the same libraries and the same stuff. So this is, we're not showing you super secret special Romi programming. We're just showing you the regular stuff that you'd use for your FRC robots. So what is this command-based programming stuff all about? Well, it's kind of a method that we came up with a long time ago, a bunch of years ago, because one of the things that we noticed was that we would go to a competition and see teams, and they'd be writing their robot programs, and it was really hard to figure out, they're maybe new to this object-oriented programming stuff, with Java and C++, and maybe they didn't know how to organize the program. And so this was a really nice way of structuring programs so that they had a lot of really good characteristics, like that they were easy to write, they're easy to extend, they're really easy to debug and test, and you get good code reuse. So you can do stuff over and over again. And I got some good stories about some of this code reuse stuff that's really interesting. So the way this works is that when you create a robot project, and we'll do that. Grant is going to write something from scratch here. And by the way, I will say, we are taking a tremendous chance doing this live and hoping that we get everything right
work perfectly
on camera.
Okay,
this is very risky. Whenever I do this, I'm doing a class or something, and I do this live stuff, it usually works, but then sometimes I forget something or something like that, and then it's like, pressure. I'm under the lights. There's all this pressure. But anyway, we'll see what we can do. So when you create a robot project, you get a bunch of files, and one of them is called main, and that's the thing that kind of launches your robot program. There's another thing called robot.java. That's this, and there's corresponding files for C++. So there's robot.java, and that's the part of the thing that kind of controls the flow of the program. And you'll see that in a little bit. And then there's this other file called robot container, and that's where we create a lot of this stuff that we're going to use, a lot of these classes and other things that we're going to use for writing our robot program. And then we have robot container. We have constants. There's a constants.java file, and inside of there are all these kind of global constants, like port numbers and things like that sensors are plugged into and that motors are plugged into. And so we keep it there so it's actually really nice that it's there, because then when you're ready to wire a robot, you can just print out that file and hand it to the guys who are doing the wiring, and they'll know what things are supposed to be connected to what. So that's kind of nice. So the robot.java file kind of looks like this. It's got a bunch of these methods in it. There's this robot init method, which creates one of these robot containers. There's a robot period. The way this stuff works is that about every 20 milliseconds, there are these periodic methods, these periodic functions that keep getting called in your robot program. And so you kind of advance the robot a little bit, make it do a little bit more stuff, get a little bit further in whatever it's doing, its autonomous routine, or you read the joysticks and then send stuff to the motors. And that happens kind of every 20 milliseconds. That's 20 thousandths of a second. So there's this robot periodic function here, or method, and that's scheduling these commands that we're going to talk about a little bit. And that happens each time this loop happens. There's some stuff here for initializing your autonomous program. There's some stuff for initializing your the teleop program that you have. So when you switch modes between autonomous and teleop, then those initialize. And there's a bunch of other methods that are like that you'll see. But generally speaking, you don't have to do anything to the robot.java file. That pretty much has very, very few changes that you might have to make to it. The robot container is where you're creating all of these subsystems and commands that we're going to talk about that are the basis of command-based programming. And so here's some examples of that. There's a function here where you might configure button bindings. So if you have a joystick with a bunch of buttons on it and you want it to control different functions on the robot, you might put that there. And there's another function here that gets the autonomous command. And you may be getting that through a dashboard, so you can pick one of many autonomous programs to run depending on maybe who you're playing with or what side of the field you're on, or which position you're starting on, or any of that kind of stuff. The fundamental thing with one of the fundamental things with command-based programming is that the idea is you want to break up your robot program into the subsystems that are on the robot. That's like a really good way of breaking up the program and structuring it so it's really easy to find things, and it keeps all the stuff together for each subsystem. So in this case, this is the little FRC robot we're going to be demoing a little bit later. And it's got a drive base, and it's got a chassis, and it's got an arm, and it's got a gripper on the end. It's a little bit hard to see. This is in my office. It's like loaded with robots and stuff. So it's a little cluttered. But anyway, so that's the robot we're going to use a little bit later today. So subsystems represent an encapsulation of all the code you need to operate a particular robot subsystem. So like arms, drivetrains, elevators, grippers, that kind of stuff. So all those things where you'd point to it and say, oh, that's the elevator subsystem, and that's the arm, and that's the chassis. All of those things are separate subsystems. And you would create these subsystems that do that. And you'll see how to do that in just a minute. It's pretty easy. The nice thing about this is this implements, as you learn more about computer science and you take more classes, there's this thing called the single responsibility principle. And the whole idea is that you want each of these classes that you write to only do one thing, to only be concerned with one thing in your program. So you don't want to write a single class that does the arm and does the chassis and does something else, because it just makes it hard to modify. If the different functions for all of these pieces of the robot are spread throughout the whole program. So the idea is each subsystem just controls its subsystem. And that's kind of how this works. So here's kind of an example. Here's a subsystem, an example subsystem, and it's got this periodic method. So fundamentally, all the subsystems have this. So again, every 20 milliseconds, this periodic function is called. But you really want to add more stuff to your subsystem to make it real. So here's like a more real subsystem. This is the hatch subsystem for some FRC robot that may want to pick up hatches and put them somewhere. And so, it's got some sensors in it, like these double solenoids. And you put those inside the subsystem because you want the subsystem to be the thing that knows about the actuators and the sensors and all that kind of stuff that go with the subsystem. And then you put in some methods, some functions in the subsystem that can operate it. So like grab hatch and release hatch are two functions, two operations that the subsystem can do. So you just put that stuff into the subsystem. Now it's not actually the code that does the whole this big long process. It's just the stuff that gets the hatch solenoid going in the right direction in this case. So it either makes it go forward or makes it go reverse, so that the pneumatic system that's doing this goes in or goes out. And so that's the idea, that all the stuff to control the subsystem is in the subsystem class. So we're going to write a chassis subsystem for the Romi, and by we, I mean Grant.
Yeah.
And I'm going to heckle while he's doing this. So what we're going to do is switch from the presentation and go over to VS Code, which is right here.
Excellent.
And then we're going to switch places and see what happens.
Thank you, Brad. Okay, so we're starting off with a completely blank slate. We have no project made, so we're going to do that first. So we're going to type create a new project. And here we are. So we're going to not choose an example. We're going to choose a template. We're going to do a Java project here. And finally, we're going to do a command-based robot. So this is what you might want to have. We're going to select a project folder. I am just going to do I'm just going to do Brad's main folder. Sorry, Brad. And we're going to select that. And then we're going to enter a project name. And we're going to call this Romi Demo. And of course, because I'm a Team 190 mentor, has to be Team 190 here. So we're just creating a blank project here. And we're going to click Generate. And we're going to say, keep it in the current window. Yes, please. So we generated a bunch of stuff. You can see some files, some directories on the left. At the bottom, we just built the project. Basically, it just compiles, makes sure that the code that was automatically generated is proper code, and it is. It says build successful.